Hello and welcome to lesson number 2 in the Grok Linux series. In this lesson we are going to continue our broad overview of Linux. We are now moving from kernel space to user space. So I know that many of you are itching to get started. This week's lesson is an overview of Linux, so I'm just kind of showing things. Next week we're actually going to get started and you're going to be learning all these commands and so on and so forth. For now, just to show you how, to help me in showing you some basic concepts, I've set up a VM. It's running CentOS 7, and I'm going to be using some commands, to show you some things. Don't worry if you don't know the commands just yet. Don't worry if you feel a little bit lost. This is just an overview. Next week we'll actually start working with the command line and you're going to learn these commands and you're going to learn a lot more about this stuff. So this is really, just an overview. Don't worry if you feel a little overwhelmed. So, like I said, I've got a VM here running CentOS 7. And I've just booted this system, and the first thing you see when you boot a system, a Linux system, is this login screen. The first thing you got to do is log into the system. So, to log in, type your username and you type your password. For users who are local to the system will check for that user in a file called etc password. So I just looked for the line containing Daniel in the etc password file, and here it is. So here's my username, Daniel. Don't worry about all these fields. We're going to get into them more in a bit. But my username Daniel, that means the Daniel user is on the system. All users are in this etc password file. My UID 1000, okay, that's just my user ID on the system, my numeric user ID. /home/Daniel, this is called my home directory. We'll talk about that in just a minute. /bin/bash, so that's what we're going to talk about right now. /bin/bash is my login shell. So when I log into the system, it starts a shell for me. Now, what is a shell? Essentially, you're looking at it. This right here, the screen you're looking at, is essentially a shell. The shell is a program. It's a special program. It allows me, the user, to type commands at the command line and have the system execute those commands. Beyond just allowing me to type commands, the shell also has a very basic programming language that supports branching and loops and so on and so forth. And so when people talk about shell scripts, they're talking about using this shell-provided programming language to create files that do things and have logic, right? So a quick example of that, for I in 1 to 5, do echo I, done. So this is just saying for the 1 to 5, the range 1 to 5, so 1, 2, 3, 4, 5, print I to the screen, and each time through the loop, the number is stuffed into I, basically. I is a container, it's called a variable, so 1, and then the next time through, 2 is in I. So if I echo that, as we can see, 1, 2, 3, 4, 5. So the shell has a very rudimentary programming language concepts. So every Linux system has users, and many, on your home computer, you might just be the only user on the system, the only human user on the system, I should say, the only human that accesses the system. In most environments, so if you have a server, there are probably hundreds of users, let's say, and each user has their own set of files and whatnot, and you have web developers, they are users, and you have sysadmins, and they have a user account, and so on and so forth. Every Linux system has a user known as the super user. The super user can do anything at all. They're the one who controls everything about the system, okay? The super user is called root. So they have an entry in the etc password file, like every user who's local to the system does. And here we can see root, and root always has a user ID of 0. And they have a home directory, which we're going to get back to in a minute, of /root, and then /bin/bash as a login shell. Now, root can do anything on the system. So you essentially, you don't want to log in as root. You want to log in as a regular user because root can screw a system up completely. Root is used for system administration. So if you need to perform some system administration task, let's say, such as formatting a file system, you would use the root user. So the file system, this home directory here, and I wanted to get into directories. So the kernel provides a single hierarchical directory structure, okay? What does that mean? I think the best way to understand what that means is to contrast that with Windows. Windows provides for each device, so for each hard drive, let's say, you have a completely separate file system. So you have a C drive, a D drive, a CD-ROM drive, etc. So these are all separate file systems in Windows. In Linux, Unix, you have one single starting path for everything. Everything is under one directory structure. So what does that look like exactly? That looks like, let me come over to my image here, right here. So everything starts in the root directory. Root directory is /, and it's kind of like a tree. Everything branches out from the root directory. So /bin, bin is a directory in the root directory, /bin, and then the file ls. I've marked every file with a square box, with a rectangle actually. So /bin/ls, and ls is a file, and bin is a directory. /etc/password, password being the file, etc being a directory, etc being a directory in the root directory. /home, /Daniel, /Java, /hello.java. Okay? So home is a directory in the root directory, Daniel is a directory in home, Java is a directory in Daniel, and hello.java is a file in the Java directory. So when I say /home, /Daniel, these are this is called a path name. So every file has a path name and it has a path to the file. So /etc/password, that is a path. A path consists of characters preceded by an optional /. So optionally this / here. Okay? All but the last component in a path are directories. So /home, /Daniel, /test1. Okay? So if we look here, all but the last component are always going to be directories. Home is a directory. Daniel, it's not the last component, it's a directory. Test. Test is the last thing in the path. It can be a file or a directory. In this case, test is a file. Path names can be absolute or relative. So if I try to ls, which lists the files in a directory, if I try to ls etc, it's going to say no such file or directory. So if it does not have the / in front of it, that is called a relative path, and it is relative to the directory that you are currently in. So if I type in ls etc, I'm saying list the files in etc in the directory I'm currently in. And you can see the directory you're currently in by typing pwd. I am currently in /home /Daniel. Now, a relative path always begins with the /, okay? And it's saying show me the etc directory in the root directory, /etc. And there we see files. The current working directory, like I said, is the directory that we are currently in. And as you can see here, my current working directory is /home /Daniel. And if I type in exit, actually, you know what, let's do this. cd to /, that means change directory to /, cd to /bin. So type in present working directory, and I see I'm in bin. Now we exit, and we log back in. Type in pwd, and you see I'm in home Daniel again. Why? Let's look at Daniel's entry in the etc password file. And you can see that it has this home Daniel. That is Daniel's home directory. That is my home directory. The home directory is the directory owned by me that I can read and write to. So I'm able to create files and whatnot. This is where I store my files. Similar to the folder in Windows that is your user folder, which I think the path to is C users, Daniel. So it's similar to that. It's my directory. So Linux has file types. Everything in Linux is a file. So this includes your devices like your keyboard, your hard drive, your mouse. Everything is a file, including devices. So if I cat dev input mouse 0, it's going to say permission denied. That's because Daniel does not have access to this file. However, recall, the super user does. So many people think SU, super user, but actually it's switch user. So I'm going to switch user, and if I said a name here, Bob, I would be switching to the user Bob. But if I omit the name, I'm switching to the super user, to root, and it prompts me for a password. I type in my password, and I am now root. So now if I cat /dev/input /mouse 0, /mouse 0, and I move my mouse, I see a bunch of junk printed to the screen. Everything is a file, including devices. Under the hood, the kernel knows what to do with these files. So you use the same system calls to perform all input and output on every file, including devices. The kernel knows what to do. So there are different types of files in Linux. There are ordinary files, there are directories, as we've discussed. There are pipes, sockets, symbolic links. So we'll discuss pipes and sockets a little bit more. We'll discuss those later. And we'll discuss symbolic links in more detail later. But for now, ls-l. -l means long listing, /. So list the files and directories in the root directory in /. And we can see that this one begins with an L. That means it's a symlink. A symlink is basically a link to another file. I liken it to a shortcut in Windows. It's a shortcut. You've created a shortcut to another file. Okay? D, this D here means that it's a directory. A directory, boot, for example, and we've got nothing but symbolic links and directories in the root directory. Now if I ls here, ls-l, sorry, we see dash. Dash means that it's a regular file. So D is directory, dash is just a regular file like a text file or an executable being a program, and symbolic links. So file names can be up to 255 characters. They can contain any character except for the / because that delimits paths, and null. So best practices on naming files, I tend to stick with typically lowercase, but you can use lowercase or uppercase. 0 through 9, underscore, and dash. Those are the characters that I would recommend using. Now, another thing to note is that Linux is case sensitive. So if I cat, which means display the contents of a file, if I cat test1 and display the contents to the screen, I see this content. That is the content in this file, test1. Now if I cat test1 with a capital T, I see entirely different content. The cat jumped over the moon rather than a bunch of gibberish. Notice that these are two different files. One is lowercase test1, one is uppercase test1, or test1 with an uppercase T. Every file is owned. it has an associated user ID and group ID that indicates what user and group the file belongs to. So, when we did the long listing here, we see Daniel, Daniel. That means the user Daniel owns this file and the group owns this file. Okay? If I do an ls-l on slash, we see that root and root owns everything in this slash directory. Okay? So ls-l, and we see Daniel and Daniel. The user Daniel and the group Daniel. Okay? Now what this means is that the user, this one's pretty obvious, the user Daniel owns this file. There's also on this system a group called Daniel. Every member of that group, so I could put other users in the Daniel group, I could put Bob in the Daniel group. Every member of that Daniel group also has ownership of this file, in a sense. For each of these, there are different permissions. So these first 3 bits here, this R, W, and this dash, indicate the permissions for the user who owns the file, in this case, the user Daniel. The next 3 bits, the R, W, and dash again, they indicate the permissions for the members of the group Daniel. The last 3, this R dash dash, these indicate the permissions on this file for everyone else on the system. So the first 3 are user, the second 3 are group, the final 3 is everyone else on the system. What this means is that the user Daniel has read and write permission to this file. Everyone in the group Daniel also has read and write permission to this file. Everyone else on the system only has read permission to this file, read. So they cannot write to this file. There's another bit that's missing here, okay? And if I change the permissions on this file, and now I do an ls-l, I see that the user Daniel now has RWX. The X means read, write, and execute. Now, everyone in the group has just read and execute. They can no longer write to the file. And everyone else has read and execute. Execute meaning run, like a program. Directories have their own permissions, and directory permissions are a little bit different than file permissions. So this is a directory, we can tell by the D there. This has read, write, and execute for Daniel, read, write, and execute for everyone in the group Daniel, and read and execute for everyone else. Now it seems weird to have execute permissions on a directory, considering execute means to run like a program. The read permissions on the directory allow the contents of the directory to be listed. So ls test. Okay, and I can list the contents of the directory. So if I remove read permissions from test and I do ls test, I can no longer read the contents of the directory. Okay, so that's what read does on a directory. Write allows me to read or create files and modify files and delete files in the directory. The execute permission is the kind of strange one. Execute allows me to access files in the directory. So ls test, and there's blah, and I can cat test blah, chmod, so change permissions here, and remove x on test, and then do a cat, and permission denied. If execute is not on there, I no longer have permissions to access the file. Now, if we add the execute permissions back and cat, we have permissions once again to be able to access the file. So the next set of topics up to the end of this video are all somewhat advanced. And actually, you know what? I'm going to make a different video for the advanced topics. I highly suggest you take the video for the advanced topics, but if you decide not to, I'm going to cover one thing in the advanced topics, and that's signals. There's just one thing that everyone should know, and that is if I type the command cat at the command line here, suddenly I'm sitting here and cat will take the input from the keyboard and output it to the screen. But oh great, how do I get back to my command line? This is the one thing that is really important. Just memorize and know this. To get back to the command line, to kill this process, to stop it, hold Control and hit C. Control C will take you back to the command line. If you have a process running and you hit Control C, it will kill the process. It will end it. So that ends this video, and in the next video we're just going to cover a couple advanced topics.